All right. It's a Friday. I know. I first thought that I would just go over more trigonometric rules, but I said, hey, it's gonna be the weekend. Why don't we just go over some easy rules and get on out of here? I know, thank you. Yes, I'm such a great teacher. I know already. Right. But we still have just a little bit more work to do, and then we can go and enjoy the weekend. So, in any case, though, we have two rules to talk about here. We have the exponential rule. Now, this rule is what I believe is the most easiest rule, but also the most easiest to forget and to make mistakes on. Eh? What do you mean by that? Well, let's take a look here. We have the integral of the natural number e raised to the u power du, and that will mean it turns into e to the u plus c. Ooh, real scary. I know. This is a rule that is very easy, but like I said, very easy to make mistakes on. So, why don't we do a very quick example here just to show you what kind of failures I've seen on these types of problems. Let's do the integral of e raised to the 2x dx, and let's see what comes out from that. Now, a student will just go, oh, that's so easy. I've got this. This will turn into e to the 2x plus c, and we are done. I get to go home now. No, you do not get to go home. This is very wrong. I know. Why, you might ask? Well, the telltale question, did you check? No, you did not. Of course, with this, we still have to take its derivative to see if we remained in the correct sense of the coefficients and the result of this integration. But then, of course, oh no, but I followed the rule. I did exactly what it said. No, you didn't. This still implies that you need to check for all of the coefficients to match exactly what was inside of the integral. These answers mean nothing if it is not confirmed that you are matching what you started with. And would you look at that? We have e to the 2x plus c as a proposed answer. If we take its derivative, oh dear, we have chain rule cropping up on us already. It's going to become e to the 2x plus 0, but we have a 2 sneaking in here. Why? Because a 2x needs to take its derivative when leaving the e to the x, and that results in a 2. Oh no, what we gonna do? The chain rule got us more than me and you. Well, in any sense though, this got you really good. So this 2 here needs to be accounted for when dealing with this problem. So in actuality, our result here is that e to the 2x, its integral, must require a 1/2 coefficient to deal with the 2x coming off of the e right there. And so we get the remainder coming out as e to the x plus c. And so with that right there is the correct answer. You've proven my point just perfectly, that although this rule is very easy for what we have listed there, the mistakes are just as easy. Now let's do one more rule and let's see where this goes. And here we are at our second rule for the day, something I like to call x in the exponent rule. What could that mean? Well, what if instead we have an actual constant number, a, raised to the u power, u containing the x's for the function? Well, we can indeed take that integral. It will look something quite similar to the e to the x, because e was also just a number, but it will be a raised to the u power over the natural log of a plus c afterwards. But there are some rules. It will state here that where a is greater than 0, so it must be a positive number, and it cannot be equal to 1. Of course, with 1 being raised to any power, that's still just going to be 1. So we have these conditions and this function to deal with. Well, where did this even come from? Glad that you asked. This shows a lot similar to what we actually talked about earlier. If we have e raised to the u power, just remember, e is a number, that lovely long natural number which no one has any clue why it's used. I'll have a lecture about on that later. In any case though, we have e raised to the u. Now, could this follow that rule? Yes, yes it can. Where in this case, if we followed the same logic though, because it's any number raised to the variable's power of u, it's going to be e to the u over the natural log of e. Natural log of e? Wow, the very basics of the natural log lets us know natural log of e to the first power is just 1. And would you look at that? E to the u coming out of the integral? Who? That is exactly the rule that we talked about earlier. It looks like this is simply an expansion of the rule for e to the u. So, in any case though, another question arises. How do we take this guy, this answer, and how can we check it? Because I thought that checking integrals are the most important part. Wow, what great observations my students are having. Of course we can check it, but I'm sure we might have forgotten the derivative rule if we took this guy's derivative. So let's have a look here. With any a to the u, and we take that derivative, because u again has all of our exponents, or in this case variables in that exponent spot, we'll come up with the following. And so from here we get the resulting a to the u multiplied by the natural log of a. That is the resulting derivative. Remember that the natural log of a, being just a number, makes no difference whether it was down there in the denominator or up here as a coefficient. Again, it's just a number. But this should be quite useful for us to finally understand how these kinds of problems work. So let's have a look here. Why don't we do something very nicely and about the same example? Let's make sure that we note it as such. And so we have 4 raised to the 2x power dx. How can we use that rule to help us? Well, of course, we get that same number. Again, a in this case, if you want to make a note, is 4. So let's see, it's going to be 4 raised to the 2x power over the natural log of 4 on the denominator. Of course, if a is equal to 4, we still followed both rules, that a was greater than 0 and a was not equal to 1. Very good. And so with that, if we called it a plus c and walked on out of here, we would be home free and enjoy the week. Absolutely not. How many times do I need to remind you that we need to check our work? We are not done. Because I'm sure with many people's trained eyes here, we have something going on. That 2x in the exponent will come down from the chain rule one way or the other if we took its derivative. So we have something to deal with here. With the 4 raised to the 2x power, if we took this guy's derivative on itself, it's going to give us some problems. Because the 4 to the 2x will stay, that's nice. But then with the natural log of 4 coming out, based off of the derivative rule, that's also fine. But we have a 2. A 2 coming off of the exponent, because we will take the derivative of 2x as the next layer on chain rule. This guy, that will be the destruction of many of the students. So we need to counteract that. So why don't we do our final answer here after our wonderful check that we need 1/2 times 4 raised to the 2x all over the natural log of 4 plus c. Now this guy, this is the good stuff. That's what I want to see, making sure all of my students check their work before running off with some random rule that they know nothing about. All right, I think that will wrap it up for today. We'll be back next time with some more example problems, and I'll see you all then. Enjoy your time away from me, I hope.